developed the world's first network roller shutters, having the world's lowest standby power, to protect houses from bushfires, wildfires, hurricanes and cyclone environments. This video will show how this world's lowest standby power technology can be applied with home network and home automation systems. Network roller shutters can connect up to 10 shutters and 10 sensors to one TFT LCD master controller. We will show you how we can add home network and home automation systems to the network roller shutters and still have the world's lowest standby power consumption. As you see here, we have replaced some roller shutters by components of home network and home automation systems, including some home security devices. Number 3 controller is now connected to a 20 Nm motor that can raise up to 32 kilograms, and number 4 is connected to a 10 Nm motor that can raise up to 16 kilograms. Number 5 controller is connected to a roller screen motor, and number 6 is connected to a 75 watt resistor load or to a 150 watt resistor load. Number 7 controller is connected to an emergency lamp, and number 8 is connected to a siren as a home security device. Number 9 is connected to a lighting system which has no battery as an energy backup. Number 10 is connected to an air conditioning system, which again has no battery backup. Let's show how the world's lowest standby power in network roller shutters works with home network and home automation. A total of 100 meters of signal wire is used to connect the devices. Enough for the biggest house. Number 1 controller is connected to a roller shutter and a wind sensor, so that this window is protected from a cyclone or hurricane. Number 2 controller is connected to a roller shutter and a fire sensor, so that this window is protected from a bushfire or wildfire. Number 3 controller is connected to a fire sensor and a motor that can lift up 32 kilograms. Number 4 controller is connected to a fire sensor and a motor that can lift up 16 kilograms. Number 5 controller is connected to a fire sensor and a roller screen motor. Number 6 controller is connected to a 75 watt resistor load, or to a 150 watt resistor load. The 150 watt resistor load is for testing and overload condition. Number 7 controller is connected to a fire sensor and an emergency lamp operated by a backup battery. Number 8 controller is connected to a siren as a home security device. Each device connected to number 1 to 8 controller is powered by its own backup battery. This means it will work also when the mains power is cut. Number 9 controller is connected to a lighting system. This system is using a modified network roller shutter PCB and buttons. This lighting system has no battery backup, so it can only be operated when the mains AC power is connected. All house lighting can be controlled here. Number 10 controller is connected to an air conditioning system. The system is again using a modified network roller shutter PCB and buttons. This air conditioning system also has no battery backup, so it can only be operated through mains power. All the house air conditioning can be controlled here. The fan represents the air conditioning system. Finally, a TFT LCD master controller is connected to this demonstration system. The power meter shown here measures the electrical input for the entire system. All devices are connected to the signal wires, so now let's check the standby power required. The total standby power is measured as 0.9 watt. This shows that the 10 roller shutters, 10 sensors and a TFT LCD consume 0.9 watt of the standby power. Let's check the room temperature. 18 degrees Celsius is measured. The standby power meter is used to compare our system with other home appliances. Let's measure the DVD player standby power. The working voltage is 244 volts, and the power rating is 0.4 watt. This is the average standby power according to government data. Let's check the Blu-ray player standby power. The working voltage is 245 volts and the power rating is 0.3 watt. Let's check a 10-year-old LCD TV standby power. The working voltage is 244 volts and the power rating is 1.5 watt. Let's check a new LCD TV standby power. The working voltage is 244 volts and the power rating is 0.2 watt. This new LCD TV has significantly lower standby power than the old one. Let's check that the network devices are operating correctly. Let's see a demonstration that all devices can be operated by the remote controls. Shutter 1 is located in the dining room. We will operate the shutter by using the TFT LCD master controller remotely. Let's raise the shutter. The shutter is rising now. Let's stop the shutter. Let's lower the shutter. Let's stop the shutter again. Shutter 2 is located in the lounge. We will use the TFT LCD master controller to remotely operate this shutter. Let's raise the shutter. The shutter is rising now. Let's stop the shutter. Let's lower the shutter. Let's stop the shutter again. Let's check the 20 Newton meter motor. Look at the motor. The motor is rotating. Let's stop the motor. Let's check the 10 Newton meter motor. Does the motor rotate? Let's stop the motor. Let's operate the roller screen motor. Can you see this motor rotate? Let's stop the motor. Let's look at the resistor load to see how it operates. Let's push the up button. The green LED lights up. Let's push the stop button. No LED shines. Let's push the down button. The red LED lights up showing the current is reversed. Let's stop it again. Let's demonstrate how to remotely operate the emergency lamp. Let's turn on the emergency lamp. Can you see the lamp shines? Let's turn off the lamp. Let's operate the siren, a home security device. Do you hear the siren? This time, let's operate the lighting system. Do you see the lamp turn on? Do you see the lamp turn off? Finally, let's operate the air conditioning system. Let's turn on the air conditioner. Let's stop it. Now, let's see how the remote monitoring works. We will use the air conditioning system to check. Let's turn it on by pushing the air conditioner button. Can you see the fan start? The TFT LCD master controller displays animation to show this. Let's stop the air conditioner. Do you see how the TFT LCD shows it has stopped? This time, let's check the roller screen motor to show the remote monitoring. Let's turn on this motor. Can you see the motor starts rotating? The TFT LCD master controller also shows the spine animation. Let's stop the motor. Do you see the TFT LCD shows it has stopped? Now, let's see the self-diagnosis, one of the important functions in home network and home automation. Let's see how the self-diagnosis works for a resistor load which simulates a broken motor. We have two simulators. The first one is 75 watt, the maximum power that the motor uses. The second uses twice this maximum electrical power. It acts as a faulty motor. We will now monitor this second simulator. Can you see that the green-colored motor icon changes to red? We choose shutter 6 which is connected to the 150 watt simulator and attempt to lower it. When we press down, it stops straight away and the motor icon turns red indicating an overload. This shows that there is a problem at the motor for shutter 6. Hence we can fix it easily. This icon shows the current temperature of the battery. The next icon its degree of charging. And next one if preset time is set or not. The clock turns green if it is set and turns gray if it is not. This time, shall we see how the shutter goes to the preset my position? We will use shutter 2 for testing this function. We mark the preset position using the red color tape. If you press the My button, this shutter will rise up to the preset height, chosen by the user. Now, press the My button for the selected shutter. It rises to the preset position which we marked. You can preset the time for the shutter to go to a chosen position. You may find this function valuable. This time, let's look how to operate the system during an emergency situation when the power is cut off. We program the siren and emergency lamps turn on, and also the entire network of shutters to close. Each controller has a high-quality lithium-ion battery, so even without a commercial power supply it will work. We can roll the shutters down, up to 70 times from the fully charged batteries. The wind sensor activates the entire network of shutters to close, and the siren and the emergency lamps to turn on. In a cyclone or hurricane, can you see how the system protects your windows from tree branches or even trunks blown by the high winds? It is not activated in low wind conditions. Can you see that only high winds will activate the sensor? All shutters close automatically and the siren and the emergency lamps turn on. The system operates well to protect property and human life during these natural disasters. Again, the total standby power is 0.9 watt. Let's see how much standby power each device used. If we measure the total standby power first, and then we remove the TFT-LCD master controller, the change is the TFT-LCD standby power. The one charger provides power to the 10 devices. By measuring the charger's standby power while it's connected to these devices, we can calculate the standby power. Let's do it. We detach the TFT-LCD master controller from the network wire. We measure 0.7 watt. So we know that the TFT-LCD master controller consumes a standby power of 0.2 watt. Now, let's measure the standby power for the charger alone. The charger alone uses 0.2 watt of standby power, while when connected to the 10 devices it used 0.7 watt. Hence, we know that the 10 controllers and 10 sensors consume 0.5 watt on standby. Each controller with sensor must use only 0.05 watt standby power. In conclusion, the world's lowest standby power technology of network roller shutters can work with the home network system and home automation system. If we connect any additional devices, each will consume an additional 0.05 watt as its standby power. This is the world's lowest standby power technology. If you are interested in this world's lowest standby power, contact me by this email. Our technology could be used worldwide to protect properties and human life from natural disasters. Its low energy standby power would reduce energy consumption.